Now we are going to see something called short circuit evaluation in JavaScript. Now this is a very important concept, so I would request all of you to pay attention to it, because many times this will come, and if you know the fundamentals of it, then it will be very much simple later. So the idea is simple. The idea is that if I am having a logical expression, something like this, expression 1, something, so here any expression is there, and here there is any expression, then do we need to evaluate expression 1 and expression 2 both in order to find the value of this whole expression? Or let's say there can be three expressions also, expression 1 and expression 2 and expression 3. So do we need to evaluate all the three expressions? That is the question. The answer is no, we don't need. Why? Because what is the idea? The idea is that I want to say this whole thing is truthy or falsy. Now, as soon as I get my answer, then why do we need to go further? So, for example, in case of AND, what is required is that everything should be truthy. So, till the time we keep on getting truthy, then we can move forward, right? But as soon as we get the first falsy value, then we know that the whole expression has to be falsy. Then why to go ahead and execute that? So you understand? Let's say in this example, expression 1 is truthy. Then I know that, okay, this thing is truthy, and for this, in order to find whether this whole thing is truthy or falsy, everything needs to be truthy. So if first one is truthy, then I need to go forward to look that whether the next one is truthy or not. Or if third expression is there, then again this is truthy, then I need to go to the third expression to see whether it is truthy or not, right? But let's say this first expression itself came out to be falsy. Then I know that, okay, this is falsy, which means that this whole thing has to be falsy. Because what is the condition? The condition is that in case of AND, the whole thing, the both of the things have to be truthy, then only it will be truthy, otherwise it will be falsy. So the first one is falsy, then everything is going to be falsy. So why to go ahead and bother about executing this second one, right? And that is the idea behind short circuit evaluation, that as soon as you get the answer, you don't need to go forward from there, just break from there only and try to give some value for the whole expression. So for example, in this case, expression 1, if it is truthy, then it will go ahead forward, but if it is falsy, it will break from here only, and what it will do, it will return the last expression using which the whole value was evaluated. Means the point at which you decided that what is going to be my answer, there whatever the value you got, that only you return. So for example, here I got expression 1. If this thing is falsy, then I know that I don't need to go forward, so I will return simply this only. So if this thing is falsy, then this thing is returned. But if this thing is truthy, then go ahead and see the next one. And if that next one is truthy or falsy, based on that whole thing is defined, whole thing is decided. But you know what? See, if this thing is falsy, then definitely I will return this. Then the whole thing is falsy, and this thing is falsy. So this falsy expression represents the value of the whole thing. Now, if this thing is truthy, then I go forward and I evaluate this. But in both cases, whether this is truthy or falsy, in both cases, if simply I return this, that is enough. Why? Because you see, if this thing is truthy and this thing is falsy, then the whole thing is falsy. Then if I return this, then that represents the expression, the value of the whole thing. Now if this thing is truthy, then if this thing is truthy and second thing is also truthy, then the whole thing has to be truthy. Then again the second expression, since it is truthy, it will represent that answer. So in that case, you understand that how it is working overall is that till the time I keep on getting true, I move forward. But in that sense, if I simply say that the first false value or falsy value which I encounter, I simply return that. Okay, or I move till the end, and in the end whatever answer is there, that I will return. So in this case, I will return expression 1 if it is falsy. Otherwise, whatever the expression 2, whether it is truth or false, it doesn't matter, because I have reached it, so the last expression is returned. In the same manner, you see in OR. What is the meaning of OR? OR means that this thing and this thing, right? If any one of them is true, then the whole expression is true. If both are false, then there is no point, the whole thing is going to be false. But even if expression 2 or expression 1, any one of them is truthy, then the whole expression is going to be truthy. Now, in order to do like a lazy sort of evaluation, how do we approach that? We approach that okay, if this thing is falsy, then I'll keep moving ahead, because I know that everything has to be falsy in order to this expression to be falsy. But if this thing is truthy, then I know that in OR, if any one of them is truthy, then the whole expression is truthy. So why bother going ahead? So in that manner, if this thing becomes truthy, then I just return that expression directly from here. And if it is falsy, then I move forward and keep on moving forward if there are multiple ORs. Okay. So in this way, you can understand that in contrast to and, in case of OR, the first truthy value which you see, that you return, and otherwise you go till the end. Okay, this whole thing which I discussed, that can be generalized to multiple ANDs and multiple ORs. So for example, logical AND chain is there, let's say 3-4 expressions are there, right? So this thing returns the first falsy value or the last value. So as in this case, if expression 1 is falsy, then that was being returned, otherwise it was moving forward. So in a similar manner here, if there are multiple there is a chain of AND, let's say 3 or 4 ANDs are there, right? In that case, you keep on looking for the first falsy value. As soon as you get the first falsy value, then you return that, otherwise the last value. And in the same case, in case of OR, here, like whenever expression 1 was truthy, then it was being returned. So similarly here, you keep on looking for the first truthy value. As soon as you encounter the first truthy value, just return that, otherwise you go to the end. So let's take an example of that. So let's see, I have a value something like let A is equal to true and false and true whatever, you see, something like this. Then if I print this, then obviously the answer will be false, because in order to everything to be truthy, the whole all the components have to be truthy, and I see here false. But actually, you see what has happened. What has happened is that I started from left, I saw true. So what is the rule? You see, the first falsy value you encounter, you just return from there, and no need to evaluate any further. That is what is happening here. When I encounter, so first falsy value, now this thing is true, so I move forward, and I see here false. So the first falsy value which I see here, and that's why I will not go above, I will not go beyond and even look at these values. Because why to look at these values? I know that this is a chain of and if this thing is false, then whole thing has to be false. So why bother going out? So that's why this false which is printed here is actually this false, right? And to prove that, let's see that here put some other value which is falsy but not false. Let's write 0. Then If I print, then you see 0 is printed. Let's write undefined. Then you see undefined is printed. This proves the point that actually whenever I encountered the first falsy value, then I returned that value. Now, why I am saying the first value? So you see, if this thing is true, then only it is coming here. If this thing would have been another value, let's say 0, another falsy value. So I'm looking for the first falsy value. So if this thing is falsy, then I will not even go and look at undefined. Whatever, I don't care, because I have encountered a falsy value and now it will return 0, you see, 0. So it has short circuited, it has not even gone to the further values. It just decided that what is going to be the whole value expression's answer, that I will decipher from here only, because I know that I have encountered a falsy, and in case of AND all the values have to be truthy, and I have encountered a falsy, so why go bother and evaluate others. Again, let's say instead of 0 this is null, then what will happen? Then the first falsy value I have encountered here only, and that's why the answer is null. You understand? That is what the example is given here also, that let's say it is 5 and hello and true. So what will happen? I am looking for the first falsy value. Is this falsy? No. Is this falsy? No. And then anyways I have reached to the end, so the last value will be returned anyways, that's fine. But if you see here, then I am looking for the first falsy value. Is it falsy? No. Is it falsy? No. Anyways I have reached to the end, so whatever values I am checking for short circuiting, that is not happening. I have reached at the end, so anyways this is going to be my answer, right? So the whole expression's answer is this last expression. You understand why the last expression? Because it was not short circuited before, and if it does not short circuit before, then and in the end the last value whatever it is there, that is going to be my answer. Because if this is truthy, then the answer is truthy. If this is falsy, then my answer has to be falsy. So this will represent, the final value will represent the answer for the whole expression. Let's take this thing. Now there is hello first and then 5. Now what will happen? I'm looking for the first falsy value. Is this falsy? No. So I'll move ahead, and then again this is last value, so I don't care. If it is 0, then here 0 will come, and that will represent that the whole thing is falsy. Why? Because truthy and falsy should be falsy, and that's why this 0 will represent falsy. However, if instead of 0 it is 5, then again this 5 will be written. And why that 5 will represent the whole expression? Because 5 is representing truthy, and you see truthy and truthy should be truthy, because it is and that's why this final value will represent that. So anyways, you understand, the last value, whatever its value is, if you have reached the last value, then the last value will represent the expression. However, if you can break out before that using these rules, first falsy or first truthy, then that is better, and the further expressions are not evaluated at all, which is the case here. You see that okay, first of all here and or both are there. Then what is happening? If and or both are there, then I'm trying to say that okay, first which one will be evaluated? I know that from the operator precedence, firstly and will be evaluated and then or will be evaluated. So firstly these two will be evaluated, right? Now when these will be evaluated, then false and world. Let's go back to the AND chain. AND chain, what does it say? First falsy value. First falsy value. First falsy value I have got here only. So I don't even go to world. From here only I say, from the first value, that the whole expression value is false, because this false. If here some other falsy value will be there, then that would have been the value. However, this whole expression here, because of false, this whole expression is false. Now it boils down to 0 or false. Okay, now 0 or false, what will happen? See, it is 0 or false. Now in case of or, I am looking for the first truthy value. 0 is falsy, and that's why I jump to the next one. Now again I have anyways reached to the so this thing is gone. You understand? This thing is gone. So let me write it like this. So let's say what was here? 0 false, 0 or false or what? So 0 or false or world. So you see what is happening. Sorry, no, it was and, yeah, it was and, yeah. So you see what is happening, that firstly this thing will be evaluated, right? This thing will be evaluated. Now what will be its answer? Its answer will be, since it is false and world, and in case of and, you know that the first falsy value has to be the value. The first falsy value I have got here only, and that's why this whole expression answer is false. You understand? And this will be replaced by this. And in the next step, 0 or false will be evaluated. When 0 or false will be evaluated, then what is the rule? In case of or, what is the rule? The first truthy value gets there. Now you see that 0 is falsy, right? If 0 is falsy, if it would have been truthy, you see, if it would have been truthy, then I would have got this answer only. But since it is falsy, I am going ahead towards next one. And if you reach the last value, then doesn't matter what it is there, that value will be printed. So you see that here it is false. So that's why in this case we saw that 0 or false and world, in this case this turned out to be false, and then 0 or false, I know that this, since this is falsy, then I have to go ahead, right? The or chain only returns for truthy, so it has to go ahead and then see the next value, and next value is false, means this whole expression value is false, and that's why this whole value is false. But if it would have been case something like 0 or world, then okay, I know that it is or, so I have to look for the first truthy value. So this will be false though, so I move ahead again. Short circuiting did not work. I reached the last value, so anyways last value I have reached, then that last value is going to be returned, so world is going to return. However, in this case you see that this or this, I am looking for the first truthy value. The empty string, this is empty string, like double quotes, nothing in there. So empty string, I see that it is falsy, so I have to move ahead. Why? Because if it is truthy, then only I have to break. So it is empty string, it is falsy, I move ahead, and then I reach the last expression, then anyways that is going to be my answer. So you understand that how this short circuit evaluation is a mechanism to basically reduce the number of computations sort of, and do the evaluations in sort of a lazy manner. And this is one of the important concepts in JavaScript, which will come handy to us later. So that will be all for this video. See you in the next one.